You do it like this too.
Do the Walkman.
Imagine if I was guarding a palace like this.
Oh, what's up? What's up?
What is this even for? Imagine you walked around in this. It's like, hey, don't bother me. I can protect myself. Am I racing? It's a race sport of this. Ow. Okay. All right, good job. Okay, so let's do this. I'm happy because the 45, 45, 90 triangle, 45, 45 triangle is one of the most important lessons in all of geometry. It's on the SAT a lot. So much so that they give you an example of a 45, 45, 90 at the beginning of every math section, which is pretty interesting that the SAT does that. They're basically saying you have to know this coming in, because if you look at the picture, for example, this is the picture with my crazy gloves.
Yay, math!
Good job. Yeah. Nothing beats the solo. Wait. We'll try that again. This is the picture they give you. Okay. So I know some of you have done a lesson like this before, but if you don't know what that means, it's kind of nonsense. That's what they give you on the beginning of the SAT. So we're going to talk about that. We're going to uncover it, okay? So let's just do it. Ready? Ready, class? Yay, math! Okay. So I guess we'll start. Okay. So let's say you have a triangle, and we'll draw one.
Yay!
On cue!
I didn't want to do it that time though, because I thought I'd be a loner again.
No, you actually didn't do it that time. That's too bad. Now my triangle is whack. Okay. First of all, who knows why it's called the 45, 45, 90 triangle, please?
Because two sides are 45, 45.
Almost, say it better. Not two sides.
The two x's, or where the 90 degrees is, the short leg and the long leg. Or
You're getting it. I know you know. Let's hear it.
Two angles are 45.
Two angles, all right? That's good. You have the right idea. 45, 45. Okay, so first let's classify this triangle. What type of triangle is this? Yes? Right triangle, correct. What other type of triangle is it? Yes?
Isosceles.
It is isosceles. Very good. So an isosceles triangle has two or more equal, what? Sides, and two or more congruent angles as well. Cool. So this has two congruent angles. And so what do you know about which sides are going to be congruent? Which sides will be congruent here, please? Yes?
The ones opposite the angle.
The ones opposite the angles. And, in effect, you also know that the hypotenuse is going to be longer than the legs. These are called legs, and hypotenuse is going to be longer. All right, so that's a really easy component of a 45, 45, 90 triangle, is that the legs are always the same. The legs are always the same, okay, no matter what. So now let's go through it. Let's say this was 3 and 3. And let's say we didn't know anything about a 45, 45, 90 triangle. We could still solve for this hypotenuse using what? Yes? Pythagorean Theorem is right. Okay, so let's go ahead and do it. I know you know this, so let's go through it. A squared plus b squared equals c squared. What's A?
9.
Right, a squared is 9. I'm down for that. 9 plus 9. 3 squared plus 3 squared equals c squared. C squared equals 18. Square root both sides. Is 18 a perfect square?
No.
No.
So 9 and
So you split it into two numbers in which one is a perfect square.
9.
In this case, 9 and 2.
And c equals 3 to the square root.
So the square root of 9 is 3. Very good. 3 square root of 2. Okay, so we can put that in. 3 square root 2. Okay. Now, can anyone see a link between the legs and the hypotenuse. Yes?
Alright, so pretty much the height with 45, 45, 90 triangle, the hypotenuse, you
Yeah.
always add a rad 2. So it could be like, the legs could be like 5,
Uh-huh.
the hypotenuse would be 5 rad 2.
5 rad 2. Okay, that's the first major rule. Yes?
It's because all of them are x, so x is the same.
Yeah, that's what this picture is referring to. Exactly. This picture is saying, okay, excuse me, whatever the leg is, this leg is the same, like 5 and 5, like you said, and this would be 5 rad 2. Okay, so let's try some examples. In other words, we don't necessarily need to do Pythagorean Theorem every time. Once you know, it's a 45, 45, 90. All right, so I'm going to erase this. I don't want to... No, I don't want to disrespect. I'll make it look like... All right, so 45, 45, 90 given. And let's say this was 10.
Okay.
Fill her up. Yes?
That one's 10 too. Right?
Yep.
Yeah, and then the hypotenuse is 10 times the square root of 2.
10 times square root of 2. Okay, let's make it more challenging. Here we go, 45, 45, 90 again. Now, we're going to say this is the square root of 6. Now we're getting somewhere. Okay, so what's the best place to start on a 45, 45, 90? Like that's easy, you know? Yeah, please?
The other leg, because it's the same.
The other leg is going to be the same, right? Keep that in mind always. Other leg's going to be the same, root 6. And you, sir, in the back said you add a square root of 2, right? What is it really? Are we adding a square root of 2?
We're multiplying.
We're multiplying, very good. We're multiplying the leg times the square root of 2. So what is the square root of 6 times the square root of 2? Yes?
Square root of 12.
Square root of 12. Is that enough though? No? No? Can we simplificaciones? Yes?
Mean 4 and then they'll be.
Right, okay, so you're splitting the 12 into 4 times 3, so this is 2 root 3. Very good. Let's say you weren't sure about whether or not this was the right hypotenuse. What could you always do? What could you do to check? Yeah?
2 times 3.
Oh, this 2 times 3 is 6? No, that's a coincidence.
That's a-
That's a coincidence. How can you check whether these legs and the hypotenuse are correct, in the same correct relationship? You actually said it before. How do you check this stuff? Yeah.
Pythagorean Theorem.
You can check with Pythag, right? Let's do that really quick. A squared would be what? What's square root of 6 squared?
6.
6. What's the rule when you square a square root? Chances, very good. Plus 6 again equals 2 root 3 squared, c squared. Let's do this.
That's equal to
2 squared,
4.
4 square root of 3 squared, 3. So these two are the same. So we're good. Okay, so that's how to check. Okay, let's make it more challenging. If I could, I would roll up my sleeves, but I can't. Yes, there's no room in this thing. 45, 45. Okay, now here we go. 6. Okay. What do we do now? I'm going to tell you how, but what are some guesses? Who feels like they may know? Yeah, 1, 2? Yeah? What do you think? You know? No, no? Okay. Here is the hardest part. Yeah, I feel like it too?
Yeah.
Yep. Okay, I'm going to come back to you. What is, as I stand in front of the problem, what is the idea behind the leg and the hypotenuse? Which is bigger? Celebration over. Which one's bigger, leg or hypotenuse? Hypotenuse. So that means whatever you have the leg to get to the hypotenuse, if you multiply by something, you're making it bigger, right? If you multiply by square root of 2, it's bigger. But if you want to go from hypotenuse back to leg, what do you think you do instead?
Put in the square root.
Me?
Yeah.
Well, if I mean, I might be confused with the 36 and 90, but isn't it like half of it? Or is that?
It's related, it's not necessarily half,
Okay.
but we are doing some sort of act like half. All right, who can help? To go from leg to hypotenuse, you multiply by square root of 2. To go from hypotenuse to leg, you divide by square root of 2. Okay? And that's a thing that on the surface seems simple enough, and it is if you once you saturate it, but it can get in your way. Again, to go from hypotenuse to leg to hypotenuse, you're getting bigger, multiply by square root of 2, hypotenuse to leg, divide by square root of 2. So we can do that now. We do 6 over square root of 2. Is this simplified?
No.
No, what do? Multiply top and bottom?
Square root.
By the square root of 2, correct? We're not allowed to have radicals in the denominator. So we multiply top and bottom by square root of 2 like this.
Couldn't you also just do, what's it called, to the power of 2?
Oh, you mean square both? No, because that would change the number. If you square this and square this, it changes the fraction. This is like multiplying by what?
1.
By 1. And when you multiply by 1, you don't change it, so it's a fair question. Okay, multiplying fractions across. What we have, math bobbies don't talk that way. What do we have? 6 times this becomes 6 root 2, good. Someone?
Over root 4.
Which is, what's the rule when you multiply? Yeah. Multiply root times itself, it's 2. Still not done? Yeah. Can you do it?
I wasn't raising my hand.
Oh, you're going like this?
Yeah.
I do that too. Yes?
You could simplify it, and so 6 would be 3 and
Yeah.
2 would be 1.
Right, so this would be 3 times the square root of 2. And this 2 as well, correct? Okay. Let's leave that one on the board and have you try one like that. Right, and then we have a few situation problems and that's it. So, let's go. 45, 45, 90. And 12. That's 1. And then 45, 45, 90. And let's do 12 root 6. Okay. All right. So let's rephrase. To go from leg to hypotenuse, what do you do? Still writing? It's cool. Yeah. Okay. To go from leg to hypotenuse, go ahead.
Multiply by root 2.
Multiply by root 2. To go from hypotenuse to leg, what do you do?
Divide by root 2.
Divide by root 2. Very good. Not bad, right? It's okay. 12 over root 2. And then again, we have it. Okay. Try that out for a sec. And then when you're done, you can move to this one. All right, here we go. So this is on the top, 12 root 2. Again, what's a root times itself?
Itself.
Same
The number inside, right? Yeah. So this is 2. 12 over 2 simplifies. 6 root 2, very good. 6 root 2 leg. 6 root 2 leg. Okay, here we are. What do we do to get to leg?
Divide by root.
Divide by root 2. So 12 root 6 divided by root 2. What's that? Can you divide roots in this fashion?
No.
Yeah.
Common mistake. Yeah, you can. You can. Just like you're allowed to split roots with multiplication, you can split them with division, right? So if I said 20 equals 4 times 5, I can split like this. Square root of 4 times square root of 5. I could also say square root of 20 equals For example, I could say that. I can split roots with multiplication. So if this guy's under and this guy's under, we can bring them together. So what would this be ultimately? Yeah, we have.
12 to the square root of 12.
No, we're dividing, not multiplying. Yes,
12 to the square root of 3.
12 root 3,
Oh.
right? If it was over here, it'd be 12. See it? On the top. So 12 root 3. 12 root 3. Please, question.
Why don't you just like times root 2 top and bottom, and then you get
Yeah,
like 12
Root 12. over 2.
over 2, and then it could be like 6 root 12, and then you like split it up, and then would that be 8 root 3?
You know, that's such a good point. So many students, both in when I'm teaching and when I'm helping people after school as well, tutoring stuff, they see this root on the bottom and they say, all right, well, I'm going to have to do multiply root 2 over root 2 in this situation. And we can do that, makes the numbers bigger though. So 12 root 6 over root 2, and then you do root 2 over root 2. And then what you said was 12 root 12 over 2, which is the same as 6 root 12, because these two cancel. Okay, and now 6 root 12 simplifies. The 12 becomes what times what?
4 times
4 times 3. You guys have gotten really good at that. I'm
Oh.
happy. 4 times 3. What's the square root of 4? 2. 2 comes out.
2 times 6.
2 times 6.
Oh,
12.
you have to times it.
Yeah, it's all multiplication in here.
Alright.
And so you see that they're the same. The point is, why I did all this work is to prove that it's not necessary. The idea is that if you know the rule that you can divide radicals, then you can combine these two, and there's no work necessary. So that's a really good point. I actually saw that yesterday, just yesterday. It's like root over root. 2 problems involving squares, and then that's it for today with Math Bobby. Okay, so here's a square. So I knocked the eraser down every single time. If this is a square, and I said a side is 5. What is the length of so this is given as a square. Right? It's not hard, is it? Yes?
Well, all the sides are 5.
Yes. Why would all the sides be 5?
It's a square.
Because it's a square.
And then you do the diagonal, and then that's the hypotenuse.
Diagonal is the hypotenuse. Lovely. Yep.
More.
And can you answer the question?
5 rad 2.
5 rad 2. Good job. The good news is, if we forgot our 45, 45, 90 stuff, we could just do Pythagorean Theorem and get that. Okay? And now, let's say, last problem, draw the diagonal in here, making 2 triangles.
Yeah, and then you put the 2 root 5 at the diagonal.
2 root 5, love it.
And you'd solve for the sides.
Okay, so let's solve for the sides.
Yeah, and then you just add the sides.
Almost.
Or you multiply the sides.
Multiply the sides. Very good. Okay, so we have our strategy. We're going to get the sides and then multiply them. Why do we multiply the sides?
Because it's area.
Area. Okay? Who can get it? Who can get it?
This is
Yeah.
a perfect square, right?
Yes, this is a square.
So doesn't this turn into a 45, 45, 90 triangle?
Right, that's the implied knowledge that when you have the diagonal of a square, it turns to 45, 45, 90. Very good. Okay, so now that we know that these are 45s, how do we get the leg? Yes?
Don't divide by square root of 2.
Very good. Divide by square root of 2. So that's 2 square root of 5 divided by square root of 2. Can we divide the square root of 5 and square root of 2?
Yeah.
No.
No, I mean 5 and 2 or can't
We
divide.
could, but
We could, yeah, right. We could technically, but it wouldn't simplify. So we go to our strategia. Oh, square root of 2, square root of 2. Okay, what happens?
Two cancel out.
These two at the bottom, this becomes 2 root what?
2.
No, 2 root 10. See it? Root 5 times root 2 is root 10 over 2. These cancel. So what is the length of the leg?
Root 10.
Root 10.
So root 10 times root 10 is 10.
Right. So root 10 is the leg. So yes, the area is multiplying side times side. So what is the area? Root 10 times root 10?
10.
10. Area equals 10 square units. Or units squared is a shorthand. These are great erasers. Okay. There's no question about it. This could definitely be numbers 1 through 5 type problem on an SAT. It says just this. The diagonal of a square is 2 root 5. What is the area? And they wouldn't give you the picture. So you draw the picture, get the leg like suggested, and multiply. Okay? Very good. What's a good club song? No, never mind. I don't want to do the club. Forget the club. Forget the club. We're bringing the club here. Ba bum bum. Ba bum bum. You know, I hate waiting in lines at clubs. Actually, you guys, I'm over clubs. Forget it. I'm done. I don't want to do it. You like wait in line, you know, and then people like walk in front of you. If that happened at Trader Joe's, I'd be like, "What is that?" You know, I'd be so pissed. I would actually need a shield.
Just shield whack them.
I was just like, "Whoosh." I need my hummus. Yeah, so I'm over it. But if I walked in like this, I'd be like the man. I'd be like, hey, what's up, Jack? Hey, what's up? Yeah. No, I'm going for the club, you know, it's trying to, you know, I found this in the back of the closet, you know, I'm working on my Bobby dance. Okay, I think we've expired. I'm gonna throw water on you. Okay, everyone say bye. Bye. Everyone say bye. Bye. You can. Bye. Very good.
1 minute.
1 minute.